Hi everyone, this is Zach. Today I'll be talking to you about ggplot2, which is a package for drawing plots in R. Alright, so as usual, let's load the tidyverse package first. So the ggplot2 package implements something called the grammar of graphics, which is what GG stands for. This is a coherent system for describing and building graphs. To illustrate the ggplot2 package, we'll be using the MPG data frame. Basically, it contains observations on different car models. Let's take a quick look. It looks something like this. To plot the MPG data frame, you can run the following code. And then this gives you a scatter plot that looks like this. This is a template that shows you how to make a plot with ggplot2. There are three things you need to specify. The first is the data frame. The second one is a geom function, a geometric function. And lastly is an aesthetic mapping. And we'll explain what this is in the next soon. First, we need to take a detour to discuss categorical variables versus continuous variables. There are generally two types of variables. Categorical variables have a fixed and known set of possible values, whereas a continuous variable is basically a real number that measures a numerical quantity and can take a very large infinite set of possible values. When you are representing a categorical variable, R will uses the factor data type. And one reason you might need to use it is to reorder a character vector in a certain order, which is not the natural alphabetical kind of ordering. Okay, let's look at an example of where factors come in useful. Let's say you polled the following students about how they felt about the lab. So Adam thought it was just right, Becca thought it was too easy, Charles thought it was just right, and so on. Alright. You can count how many students had each type of feeling using the counts function. Alright, what you see is the order of the feelings is basically the alphabetical ordering. Alright, but these feelings actually have a natural ordering. Let's say you ordered it from the easiest to the hardest. It would be too easy, just right, and too hard. We can change the ordering of the count function by using factors. First, we define the levels, the three levels of the feeling, too easy, just right, and too hard. And then we use the factor function to convert the feeling to a factor with the levels specified. Once you do this, then when you run the count function again, you notice that the order of the feelings has changed to the natural ordering. Alright, now let's look at aesthetic mappings. The two most obvious aesthetic mappings are X and Y. And the next one we'll talk about is color. So one of the columns of the MPG data frame is class, which represents the class of the car. And so if you color the points using the class variable, this is what you get. Notice that different classes of cars have different colors. Nice. You can also color using continuous variables. For example, there's a variable called sil for cylinders, and if you color it, you'll notice that there's something called a color bar here. So it actually can have a different color for every value that ranges from 4 to 8 in this case. Actually, in cars do not have a continuous number of cylinders. If you look at the data sets, the number of cylinders is 4, 5, 6, or 8. So you can actually treat cylinders as a categorical variable instead if you want, using the factor function shown here. Notice that when you use the factor function turns the variable into a categorical variable, so the color bar is gone and you have discrete colors, one for each value. The next possibility is to use the size aesthetic. So different points have different sizes. Although this doesn't really make sense, you don't really want to use size for discrete variables, because the classes are not really represented from smallest to biggest. The next aesthetic is the alpha aesthetic, which controls the transparency of the points, like so. But again, this is not quite, this doesn't really make sense. Usually it makes sense for more continuous variables. Finally, you can also change the shapes of the points. Notice that the SUVs do not have points because ggplot only uses 6 shapes at a time. And additional groups will not have any shapes. Finally, you can also set the aesthetics manually, like so. If you want all the points to be blue, you can do it this way. However, sometimes if you're not careful with where you put your commas and where you put the color equals blue, you might try this and you'll see that, ooh, the points are not at blue at all. So I'll leave it to you to look carefully at the code and figure out why this code is wrong. A common mistake that people make is putting the plus sign in the wrong place. So notice that the code has a ggplot plus a geom point. The plus must be at the end of the line, like the code at the bottom. If the plus is at the beginning of the line, then it splits into 2 separate statements. The first statement is fine, but nothing happens. It shows an empty plot. And the second statement will give you an error. Alright, now let's look at geometric objects. You've seen the point geom already. There's also another geom called the smooth geom, which basically smoothly interpolates the data. And it looks like this, pretty cool, if you ask me. Alright, so this is the default smoothing method. You can use a different linear smoothing method if you want, something like this. So basically it fits a line to the data. And you can even use the line type aesthetic to have different smoothers for different types of cars. In this case, there are 3 types of cars: four-wheel drive, rear-wheel drive, and forward drive. So this plot has a different smoother for each of the 3 different drive types. Notice that for smooth plots with lines, there is an aesthetic called line type, but obviously when you're plotting points, there's no such aesthetic called line type for points. You can also plot multiple geoms in the same plot, like so. Alright, so you're plotting the geom points as well as the geom smooth and kind of overlaying them on the same plot. Of course, you notice in this code that there is some duplication. The mapping is basically repeated twice. So you You can avoid this by putting the mapping in the ggplot. And the geom point and the geom smooth will borrow the mappings that were defined earlier, like so. So this gives you exactly the same output as before. The next geom is geom line, and I'll just show you a simple example. I think this one is almost the same as geom point, so I'm not going to talk about it further. Finally, we'll look at geom bar with stat equals identity. So this draws a bar plot, like so, the number of diamonds with each cut. All right, now let's talk about statistical transformations using the diamonds data frame. If you want, you might want to plot, for example, the histogram of the diamond, the carats. And this is how you do it. You just need to write x equals to the column name, and in this case I'm specifying the bin width that I want. Right, so each bin, the width is 0.5. You can also look at geom box plot, which draws a box plot for each, in this case, each class of car, and the highway mileage for each class of car. And you'll notice that different classes of cars have different mileage. You can flip the x and y axis using the coord flip function, like so. So just add a plus coord flip, and then magically the class is now on the y-axis and mileage is on the x-axis. Alright, for geom bar, you can also use geom bar to count. So you can count the number of diamonds of each cut, like so. What is quite cool is you can color the bar plot or bar chart using the fill aesthetic, and you can map the fill aesthetic to another variable, let's say clarity, and then you actually see a stacked bar plot where it shows you the number of diamonds of different clarities and different cuts. If you don't want a stacked bar plot, you can use a different position. Let's say you use position fill, then what happens is that it normalizes the height of each variable, each cut variable to 1, and shows you the proportion of diamonds with different clarities and different cuts. Finally, you can also use the position dodge. What that does is it shows you the same information but as bars next to each other. So these are the diamonds with fair cut, and it shows you the rough distribution or rough count of the different clarities for these diamonds. Finally, there are some functions that you can use to tweak the plot to make it look nicer. For example, you can use the xlab, the ylab functions to set the x and y axis labels, and the ggtitle function to set the title of the plot, like so. So you can see a nice label for the y-axis, a nice label for the x-axis, and a nice title. You can also zoom in on a plot by using the coord Cartesian function with the argument ylim or xlim equals to min max. Right, so for example, this is the original plot, and if you zoom in on the y-axis from 20 to 30, this is what you'll see. Right, so this is only 20 to 30. Finally, the last command you should know, or function you should know, is how to save your plot. You can use the ggsave function, the name of the file, and the height and the width of the plot, like so. Alright, that's all for now. See you next time. Bye!